We are going to be looking at surface area of a cube in a rectangular prism. This is also sometimes called a cuboid. And I think we've all drawn them before. There's a little cube, and a cuboid would just be maybe the same, varying different lengths. It can be a combination of either. So we talk about the base of a prism. When it comes to a rectangular prism, any of the faces of the brick shape could be considered the base of the prism. It's different for triangular prisms, which we'll get to in another video, but what you need to understand about a rectangular prism is that it could be sitting on any one of its faces and then still qualify as a prism. If you take a 3D shape and you stand it on the ground, and the base that it stands on and the face at the top are the same, it's a prism. So it doesn't matter which way you put a rectangular prism on the ground, it's always going to be a prism, but it will affect things if you stand a triangular prism or a cylinder up on a different face. So the one concept is to get the surface area of a prism, we just add up all the faces of the shape together. We can draw a net diagram, which I'll show you. Alternatively, we can use a formula. This one will work for every single one, but you're then going to need to learn the formula off by heart. I'm going to show you both methods where we add up the different shapes and where we use a formula. Adding up the shapes is going to be useful for maths literacy in grade 10, whereas using a formula is going to be useful in maths core. All right, so let's add a diagram here. If we have an example where we have a cube, and I'm just going to sketch one here. A cube implies, just the word, means that every side is the same. So one side is equal to 8 means every single side is equal to 8. So that is more or less what that cube will look like. Okay, and every single side is 8. But what we need to look at is possibly a net diagram to help us understand what this cube will look like. So if I open up this cube and if I pretend that it was, say, a present and every one of the sides was wrapping paper without any flaps, then that shape of the cube's net diagram, so the way I would have to draw it on cardboard in order to be able to make myself a cube, would be made up of 6 absolutely equal triangles, and they'll all be 8 times 8. And there's 1, 2, 3, 4, 5, 6 of them. So my surface area will be 6 squares. The way that I'm going to write that then is I'm going to say method 1, I'm going to add up all the shapes. And in this case, what I have is I have surface area equals to a square times 6. The square is length times length. And then I'm going to have 6 of them. The length of the square is 8. So I'm going to say 8 times 8 and then have 6 of them. That's going to be 64 times 6, which is going to give me 384 square centimeters. The second method, for which I will get the same answer, is to use my formula. My formula is 2 times the area of the base, and in this case they're all the same, but I'm going to take my bottom block that I've labeled block 3, and I'm going to say that is the base. So it's 2 times the area of the base, which will be 8 times 8, plus the perimeter of the base, which will be 8, plus 8, plus 8, plus 8, and I'm going to put every single one of those numbers in because this is the first time I'm showing you this particular formula, and it's going to be that multiplied by the height of the prism. And of course, because this is a cube, the height of the prism is also 8. So here, this is going to be 2 times 64, which gives me 128. And then I'm going to say, well, those 4 eighths, they are 32. And I'm going to times 32 by 8. And I'm going to get 256. Note that I'm not putting any units in until the very end. And then for my last step, I'm going to take 256 plus 128, and again, I get 384, and now I'm going to put my units in. The second question is asking me how I would do this if the cube was open on top. This time, I've got the base of the cube. I'm now going to build it from the ground up. I've got the back face, and I've got the front. I've got the left side, and I've got the right side, but there is no top. This could also be an example where we talk about a box that doesn't have a lid. Okay, so my first method is going to be to add up all of the blocks, and that's going to be a square times 5. Now we've already worked that out, so I'm going to go straight to the answer, which is the 8 times 8, and there'll be 5 of those, which is going to be 64 times 5. So my answer, if I add up all of the different squares, is going to be 320 square centimeters. Could you have just taken your previous answer and subtract 64 for one square? Absolutely, but not every question will do both. So therefore, I want to just show you how to do it from scratch. Method 2 is using the formula, but this one, you're going to need to adjust the formula. Okay, so I'm going to write here that method 2 is an adjusted formula, because the formula says we need 2 times the area of the base. That was my base, but there's no top. And in fact, the 2 times area of base was to deal with the base and the face at the top. So now I'm actually going to have 1 times the area of the base, which we know is 8 times 8, which is 64. And now I'm going to say perimeter, so 8 plus 8 plus 8 plus 8, which we worked out last time, which is 32, times the height of the prism, which will also be 8, because in this example, every measurement is 8. So that is going to be 64 plus 256, which gives me an answer of 320 again. You can use either of these methods depending on your subject choice for next year, and also depending on what suits you and what helps you understand better. The next example is going to look at a rectangular prism, and that is given. We have 12 over there and 8. So this particular face, the front and the back, they are both going to be 8 by 12s. There's going to be 2 of those. And then I'm spotting 200 millimeters, and I immediately want to change that into centimeters, because we've got to deal with all of the units being exactly the same. Okay, now the way that this rectangular prism is sitting, its base is this one. But remember, with a rectangular prism, the base could be any of the sides depending on how it's sitting. So we want the surface area, and we're trying to get lots of different measurements, and we're trying to see what those are. So I said that the 8 by 12 is your front and back. And then I want to look at the base, which is 20, look there, 20 by 12. And there's also a top. So there's also a 20 by 12. And then there's one more set of rectangles. There's obviously 2 of the 20 by 12 because it's the bottom and the top. And then there's my left and right. And the left and right are there and here. And my left and right, if you can see those, that's 8 by the 20. Now I'm hoping you can see from my pre-calculations that basically 12 appears twice, 20 appears twice, 8 appears twice, and all of the different ways in which you can multiply the different lengths or the different measurements of the rectangle are used, and they're each going to get used twice, and there's going to be 2 of each of them. Answering the first question then, method 1, I'm going to add up all of the different shapes. I'm going to say surface area equals 2 rectangle A plus 2 rectangle B plus 2 of rectangle C. Where am I getting A, B, and C from? Let me draw you a picture. For this rectangle, we could draw a net diagram. I'm going to put in the long base over there, which is from the diagram, from the 3D shape, 12 by 20. And that is going to be the base. Then I'm going to have another one of those later, but I'm going to have one on the right, which would be this one here, the right side, and then we'll also have one on the left. And those are going to be 20 by this measurement here. They're going to be the 20 by 8. So you can see now 20's come up twice. And of course there will be the left-hand side one as well, which is going to be 20 by 8 as well. And then we need to deal with the back and the front, and of course the top. I'm going to add on the top here. So it's going to be the same as that one. And it's going to be 20 by 12. And then I'm going to add on the back and the front. So let's put the back in over there and the front in over there. And that is 12 by 8. And this one's also 12 by 8. The trick is that 8 and that 8, they all have to hook up. They've got to be the same. This 8 will go with that 8. Okay. I'm going to call these different rectangles. I'm going to call this one rectangle A. There's 2 of them. I'm going to call this one rectangle B, and there's 2 of those. And I'm going to call the little one rectangle C. And that's how I'm going to map out my calculation. So, what was my rectangle A? Rectangle A is 12 by 20. So it's going to be 2 of 12 times 20, because it's length times breadth. Rectangle B was 20 by 8. So it's going to be 2 of 20 times 8. And rectangle C was my little guy. That was the 12 times the 8. So I'm going to say 2 of those, which are 12 times 8. And now I'm going to put in my calculations as I go. 12 times 20 times 2, that gets me to 480. This one over here is 320, and my 2 of the 8 by 12s is 192. My final answer for this, using method 1, is 992 square centimeters. Now let's look at doing it using the formula. Using the formula for method 2 for the first question, I'm going to need to take twice the area of the base, and I've cleared all the previous markings so that we can get our heads around what the area of the base is. And for the purposes of rectangular prism, it's whichever side it happened to be sitting on. Now it could be one of the other sides, but in this case it's the one that is 20 by 12. So using the formula, I'm going to say 2 times the area of the base, and the base is the 12 times the 20, and then I'm going to add the perimeter of the base times the height. That part's easy. It's going to be something times the 8, which is the height. Perimeter of the base, I need to transfer some numbers across and realize that that's also 20, and at the back that's also 12. So my perimeter of this base is going to be 2 length plus 2 breadth. So it's going to be 2 lots of 20. Let me just add those together, plus 2 lots of 12. And you can do this in any way that makes sense to you. Okay, bearing in mind this must get multiplied in terms of bed mass first. So what this gives me is 2 times this 240 plus 64 times 8, which is again 992 square centimeters. We can do a very short method for the second question. The prism is open at the top and at the bottom. For question B, all I really want to do is subtract the top and the bottom, and that does depend on the way in which this rectangular prism is sitting on the ground. And the top and bottom is actually 2, so it's 2 of the same. It's 2 of the 12 by 20. So I'm going to take my 992, which I got from either of the methods above, and I am going to subtract 2 of the 12 by 20, and that's going to give me 992 minus 480, and that answer will be 512 square centimeters.